All right. So 1.8% of the US population has some form of HCV, that's hepatitis C. And you can get tested to see if you have this disease, and it's accurate 99% of the time, so 99 times out of 100. And you have someone who takes this test to see if he has it, and he tests positive. And he wants to know what his odds are of actually having it if it comes up positive. And he also wants to know what his odds are if he gets positive twice. And for this, we're going to need a contingency table. So we're going to pretend that the US population is only 10 million to make things simple. And we know that 1.8% of that 10 million is going to have the disease. So that's 180,000. And that in turn means that 9,820,000 do not have the disease. So if this is a test that's 99% accurate, we know that among that 180,000, only 1% of them are going to come up negative. So that's 1,800, which in turn means 178,200 are going to have the disease and come up positive. And now for those that don't have the disease, the 9.8 million 20,000, it's going to be the opposite. We know that 1% of them are going to come up positive because these are going to be the people that don't have the disease but come up positive anyway. So that's going to be 1%. And in this case, that's 98,200, which in turn means that 9,721,800 don't have the disease and are going to come up negative. And with that, we can get our totals of 276,400 for positives and 9,723,600 for negatives. But we're only interested in the positives. And so we have 276,400 positives total and 178,200 positives who actually had the disease. So it's as simple as dividing these two to get 64.5%, which means that if you test positive, there's a 64.5% chance you actually have the disease. But those aren't very convincing odds, so our patient wants to test again. And we're going to make another contingency table. And so our total is going to be just 276,400. Remember, these are the positives that have and don't have the disease from the previous contingency table. And we already know that 178,200 of them have the disease and 98,200 of them do not. And we know that 99% of those that have the disease are going to come up positive again because this is a test that's 99% accurate. And then the other 1% is going to be 1,782. And for those that don't have the disease, the 98,200, it's going to be the opposite. 1% of them are going to come up positive even though they don't have the disease, and 99% of them are going to come up negative. That's 97,218. And now we have our totals for positives, which is 177,400. So these are the people that are going to come up positive again. And we don't need the total for negatives. That's going to be irrelevant. And so we take 176,418. So those are the ones that have the disease and test positive twice. And then we divide that by 177,400. That is the amount of positives total from the second test, and you get 99.45%. So it's a bit like the opposite of lightning striking twice. If you test positive 2 times, you know that you are almost guaranteed to have it, but not quite.